Hi students, this is Mr. Yao. Today we're going to talk about polynomials. In this lesson, you will learn about the vocabulary of polynomials. We'll be working with polynomial a lot this year, so please make sure to understand the vocabulary because we're going to be using them a lot. First, let's define terms. That is a constant or variable or product of the two. So for example, 5, that's a term. Negative x, that's a term. Or put together negative 5x, that's also a term. Next, you will see these cycles. First one is a unicycle, or actually some people will call it monocycle or monowheel. The second one is a bicycle, the third one is a tricycle. Polynomials work the same way. The first one will be called a monomial, which means there's only one term. Then it's called a binomial when there are two terms. Then it's a trinomial when there are three terms. And polynomial would be meaning all of these. Now let's see some examples of monomial and some non-examples of monomial. The first one, it is a polynomial. The second one, it is also a polynomial. The third one is not. Fourth one is not. And fifth one is not. After seeing all of these, we should be able to define what is not a monomial. First two, they're just regular variables, regular exponents. But the third one, we can see compared to the first two, the difference is the exponent is negative. That means in order to be a monomial, it cannot have a negative exponent. The fourth one, difference is the exponent now is a fraction. And that means a monomial cannot have a fraction exponent. The fifth one is not a monomial because the variable is on the bottom. That means the variable cannot appear in the denominator. So here's some bullet points about monomial or polynomial. We cannot have negative exponents, no variables in the denominator, no variables in the exponents, and no fractions as exponents. Now that we have defined monomial and polynomial and have seen some non-examples, let's practice. Out of these 7 expressions, which one do you think is not a polynomial? You can pause right here, and I will give you an answer in a minute. Okay, now that you have a minute to think about it, let's go through these. The first one, it is a polynomial. All normal numbers, normal variables. The second one is not because we do have a negative exponent, so it's not. The third one, everything is normal, so it is. The fourth one, you may be thinking, oh, I don't even have a variable. But hey, when we define a term, it can be just a number or just a variable. It could be either or both. So that actually is a polynomial. More specifically, it is a monomial. Next, we see square root. In the future, we will learn more about how to change square root into an exponent. But that actually is a 1/2 exponent, which means it's actually not a polynomial. Number 6, we do see this variable d on the bottom of the fraction, which means it's not a polynomial. Number 7, you may be thinking 1/80th. I do have a fraction, but hey, the variable is not on the bottom of the fraction. It's just outside the fraction, which is totally fine. And that means number 7 is a polynomial. Now let's talk about the degree of monomial and polynomial. Here's the definition. The sum of the exponents of the variable in the monomial. Keyword sum. And also, make sure we're counting the exponents in the variable. So for the first one, we have negative 2 cubed a to the second power and b to the fourth power. Remember, we're only counting the exponents in the variable, so it's going to be 2 plus 4. The degree is 6. Next, 8y. For that one, we don't see an exponent, but we do have a y. That means the exponent is 1. So for that one, the degree is 1. Next, just a number, 4. We don't even see a variable. That means the degree is 0. So whenever you just see a number, the degree for that one is 0. Next, degree of a polynomial. Now that's going to be different. The definition for degree of polynomial is the largest exponent of the exponent. That means you do need to count the degree of each monomial and then pick the biggest one. So the first term is a 6, next term is a 4, then it's a 9, and that's a 0. The biggest in this case is this 9. So the degree for that polynomial is 9. Please pay attention to the difference. Degree for monomial is the sum, and degree for polynomial is the largest. Next, let's look at a bit more definitions. We will be looking at this expression, 4x cubed minus 6x squared minus 1. First, if I just look at 4x cubed, that is a term and it's a monomial because it's just itself. Next, if we look at that 3 on the top right corner for that monomial, that is going to be the degree. Next, if we just look at the second part, which is negative 6x squared minus 1, that's 2 terms. So that is going to be a binomial. And next, if we look at the whole thing together, we do have 3 terms. So that is a trinomial, or we can call it a polynomial with 3 terms. Next, we are going to talk about standard form. That is when the polynomial with exponents in descending order. Make sure it's descending order. And whenever we're working with expressions or polynomials, we will always make sure it's put in standard form. Next, we do have this -1 on the end. That is a number by itself, doesn't have any variable with it, and that is called the constant. It's a term without a variable. Next, we have this -6 in front of x squared. That clearly is not the constant because it does have variables right after it. That is called the coefficient. It is the number in front of the variable in a term. Next, we have a 4 in front of x cubed. You might be thinking, well, that's no difference compared to the -6 because it's in front of the variable. Well, it is. So it is a coefficient, but more importantly, it's a leading coefficient. It's the coefficient of the first term, but is not just appearing in the first place. It is the first term when it's being put in standard form. Please make sure it's put in standard form before you find the leading term, the coefficient. So these are most of the polynomial vocabulary. We do have one more, and that is like terms. Like terms is defined as same variable and same power or exponent. So for example, 5x squared y and -6x squared y, they are like terms. But if we have, say, 5x squared y and then -6x y squared, they're not like terms because x has different exponents and y have different exponents. And for the top one, even if we switch the order of y and x, we say yx squared, they are still like terms because y still just have one exponent as 1 and x just has 2x exponent. Next, we do have different way to classify polynomials. One is by number of terms, and that's what we talked about at the very beginning. If there is one term, it's monomial, 2 terms, binomial, 3 terms, trinomial, and 4 or more. We just say polynomial with 4, 5, 6, etc. terms. What's more important is when we define them by degree. If 0 degree, that means just a number, it's a constant. If it's 1 degree, that is going to be things like, for example, x plus 2. That is degree of 1. That's a linear. Next, quadratic. That would be things like 2x squared plus 5 That is quadratic when it's square. Then we have cube, like 4x cubed minus 3. The highest exponent is 3, so it's cubic. And if there's more, we will just call it 4th degree or 5th degree, etc. polynomial. Now let's look at some more examples to practice classifying polynomials and those other definitions. First, number 1, -3. The standard form is just itself. As for degree, it's a constant, so the degree is 0. Leading coefficient. That one doesn't even have any other terms, so we'll just say the leading coefficient is -3, or it could just be no leading coefficient because there's no variable in front of x. As for type based on degree, that is a constant. Next, -2 cubed a squared b to the 4th. That is already by itself, so it's -2 cubed a squared b to the 4th. Make sure the coefficient is in the front. As for the degree, we do need to add up the 2 and the 6. I mean 2 and the 4, that gives you 6. Leading coefficient, that is this number in front, so -2 cubed. As for the type based on degree, that's a 6th degree monomial, so we'll just call it 6th degree monomial. Number 3, standard form, x squared y, that gives you 3 as the degree. So that is going to be in the front. And then we have this -25xy next, because at the map, the degree is 2. We have 75 on the end. As for the degree, it's a 3. Leading coefficient is 5. Type based on degree, since the degree 3, we can call it cubic, even though it's different variable. Next, standard form again, -10 n cubed, because 3 is the highest exponent, so that's the highest degree. Descending order, next is plus 9n squared, minus 8n, then minus 1. The degree in the front is 3. Leading coefficient is -10, and it is cubic again. Next, we have -pi x to the 4th power, and then the next one is pi over 4x. We have this 2 pi over 3 on the end. Degree, 4. Leading coefficient, -pi. Since the degree is 4, we will just call it 4th degree polynomial. Last one, we can see the highest exponent is 7, so it's going to be 6x to the 7th power minus 9x to the 3rd power and minus x. Degree, highest exponent is 7. Leading coefficient is in front of x to the 7th power, which is 6. And we'll just call it 7th degree polynomial. That's everything about polynomial vocabulary. Hopefully you understand the vocab now, and we'll be able to use them in the future. Thank you.